All right, welcome to the first video on the Biomedical Engineering 6301 Statistics course. Um, this is the first of hopefully a few different courses that I will be covering, um, and hopefully give some insight and can kind of understand from one student to another the kind of topic and content that we'll be kind of covering in this course, and hopefully it can give you some help, not only for myself but for other people. So this is just kind of a good tool to use to um, supplement, any text for maybe your course that you're in, or use as like an additional study guide. But I wouldn't recommend using this as, the, you know, go all be all for your entire class, but definitely good supplemental material. But I will cover the text that I'm going to be following and kind of walking through, and we'll have notes for the course and everything, and might be doing some practice problems and things like that. And just a general overview, step by step, walking through the chapters and everything and following along should be pretty helpful. Um, yeah, I think that covers everything. I guess I will go on to the next section, which is the textbook that we'll be following for this course. It is the Fundamentals of Biostatistics, composed by Bernard Rosner. Um, some very interesting credentials from Columbia, Stanford, and Harvard in the mathematics and statistics fields. And this is the book that I'm familiarizing myself with and will be using to kind of keep track of all the content for this kind of instruction. So I guess we'll just start right in on where Rosner starts on chapter 1. It is a general overview um, covering the basics of statistics and the different types of that within like the mathematical field, um, specifically for biostatistics. And I myself am working through a biomedical engineering master's, and this is kind of the, I guess, main book for that course. And so primarily focusing on biostatistics for kind of the premise of this course. And so um, we're going to be kind of walking through the textbook for chapter 1. It's a very short chapter, but Rosner starts it off with a good example of an automated blood pressure measuring device and the comparison of that automated device to maybe more old school, excuse me, maybe a more old school manual measurement. And so with that comes, some differences, but Rosner points out that there was like a difference in some of the measurements that were being done on some of the machines. They were kind of up on the higher end of 115 to 130, which doesn't look too promising. You typically want them a little bit lower, and I guess depending on the circumstances, but manual measurements revealed systolic blood pressures around 90 millimeters of mercury. So there was a, a difference that was noticed, and wanted to kind of go about doing some testing to try to understand, okay, what's the statistical differences between the measurements that we're using here. And so this is something that's very common in industry, and something that you want to make sure that equipment that you're using for medical purposes is very accurate and consistent and calibrated properly and everything like that. And so this is something to keep in mind. And so we have some questions for some testing that they want to do between different machines, around the area, and they want to compare those machines to uh, people who have been scheduled to sit at those machines pretty much all day and just take note of everyone that comes by and uses them. They want to ask them to fill out a kind of participation form, and then they'll ask them if they can do a manual blood test, a manual blood pressure test compared to the machine's test. and then they want to, track all that data and then use that to determine if there's a difference in these machines or not, just because they seem to be running kind of high. And so some of the questions that they wanted to ask at the beginning were, well, how many machines need to be tested? Um, and it goes down, there's different questions like how many participants should be tested? What order do we want to take the measurements? Should we test the participants on the machine, or should we do the manual measurement first? And why should we do one versus the other? Well, you could have situations where the first test, for example, the participant might be nervous and they might stiffen up, and that can cause the blood pressure to increase and maybe perform differently. And so by utilizing a system such as a coin flip to randomize which one goes first, maybe the human is heads and the machine is tails, and you flip it before the person does their test, and then whichever one it lands on, they do that one first. You also want to get a large sample size. So you want to have, you don't want to just test one person. If you want to test a multiple groups of people, so for the amount of people that they're going to be testing, they chose 100, and that was determined by utilizing means, which will be discussed later in the text. So that'll come later, but that is a good question. Like, what sample size should be used? Should you use 30 people, 100 people, 1,000 people? And ideally, what you want to do is find, and this is getting a little bit ahead of ourselves, but you want to try to find a good amount of people that will represent the population as a whole. Obviously, there's 8 billion people on Earth. You can't test every single person, but how many people do we have to test in order to get a reasonable understanding of what the population as a whole looks like? For that test that they did, it was about 100 people. And then they decided to test on 4 different machines located around the area, just to give an idea between the different machines that were used. And this is something that we should also keep in mind that isn't really discussed, but variation from machine to machine. For this test and these purposes, we're assuming that all 4 machines are operating identically, but there can be differences in the components. Maybe there's wear and tear. Maybe one machine has a lot more traffic from people using it all the time, and maybe that wears down the components more, and maybe that will give us different measurements or things like that. So something to keep in mind as well. What data should be collected on the questionnaire? So they want to have participants fill out a questionnaire. We want to check maybe their arm size could change the differences in the machine measurement or something like that. If they're putting an arm cuff on, things like age, gender, and hypertension history need to be thought about. You can't collect everything about every single participant, but what are the most important things that we can have them put on their questionnaire? And then how should the data be recorded to be read easily later? You want a form filled out, with a specific ID for all the participants, for anonymity and things like that. And you want to make sure that the data analysis program is able to be used to make sure that not only are you tracking data correctly, but there aren't any inaccuracies in the forms or anything like that. So let's say we've done this, we've sent out, our workers, they collect all the data and everything, and then they report back to us, and then we're able to fill out a chart that looks like this. Now, you can take a second to pause and read through the chart if you want. Obviously, at the top, we have the machine, the human, and then the difference, right? And that difference is the biggest thing that we're looking at. Primarily the mean. We decided to go with the average of all of the participants together. We could have looked at something like the median, but I guess for this specific example, for now, we're just going to stick with the mean and just try to understand the data from that aspect. And I think the first thing that we should look at and realize is that the number of people, we were shooting for approximately 100, and locations A and C do this very well. They get up to 98, so it's fairly close, but locations B and D don't really get as close as those ones do, and that doesn't give us as much data as that we would like. But that's something that we need to keep in mind going into statistics sampling. Sometimes you won't be able to obtain the kind of data that you need, and that's something that you need to be aware of when you're going into, determining what your sample size is going to be. It should be anticipated that you might not get 100 people for every single site, and that's okay. You can still, uh, you know, use the data that you receive to make, an understood assumption about the population. It just might not be as accurate as you would have liked, and you can go back and collect more data if you need to, but just know it might take longer. Maybe locations B and D didn't have as much foot traffic, or maybe it wasn't as close to certain neighborhoods of people checking their blood pressure as often. Yet, maybe A and C locations are near a senior living home and they need to check their blood pressure more regularly than maybe a younger person would, or something like that. So you kind of need to read the data to understand what is going on. And the second thing I want to bring to attention is the means here. So you can see location C and location D had differences in the mean of about 14 and 6.9, and that's fairly large compared to locations A and B that didn't really seem to have too much of a difference in the mean. And so what we want to do is understand that. We want to look at that and understand what that might entail. Are there actually differences based off of this? Because we want to know if there is going to be, any issues with the machines reading the measurements differently than the human would. And so, we have to do testing in order to ensure that, we can tell us how likely it is that, we would obtain a difference of, maybe 14 millimeters of mercury between two methods in a sample of 98 people. And if there was no real difference between the methods over the entire population of users, then, that can tell us what we need to know. So, with this, we want to try to understand the difference in our estimated mean difference compared to our true mean difference. And that's kind of what we're trying to look for. In this particular case, it was concluded that using a t distribution, it was concluded that the probability was less than 1 in 1,000 for each of the machines in location C and D. And so this probability is, sufficiently small enough for the conclusion that there was a real difference between the automatic and manual methods for 2 of the 4 machines tested. And so that's important to note too, that it's only for location C and D. And so with this whole process, we're using inferential statistics, which is a sample that is representative of the population. You can notice here that the sample didn't test green or yellow persons within the population, but they tested black, white, blue, and orange. And that's something to keep in mind, right? When we have a sample, we only tested, a small amount of the population. We might have not tested a single person who was, under the age of 5, or over the age of, 100 or something like that. But we're trying to get a representative sample of a large population, and that's something we're going to see a lot within the medical device field, within biostatistics, and within kind of the healthcare industry as a whole. Is we're trying to understand the entire population without having everyone in the population contribute to the data. And so that's something that we're going to be trying to understand. Another thing to understand is that we will be using statistical software to analyze a lot of this data going forward, whether that's SAS, SPSS, StataR, Minitab, and Excel. I personally really prefer Minitab and Excel. That's what I have experience with, but there are other options that are available out there. And so this is a quick, brief introduction to kind of what this course will look like. There's going to be a lot of statistics, a lot of it related to the biomedical field and everything along those lines. Thank you, and I will see you guys in the next chapter.